All right, we're back for more Shenzhen IO, and it's been a little while. I took a 3 week vacation. Um, they apparently haven't fired me yet. So I think what I'm gonna do is revisit the problem we ended on last time, and I'm gonna see if I can figure out what I was doing and refactor this. And after the stream ended, I did play around with it, and I was able to get down to just 2 chips. Um, So as a warm up, let's see if we can recreate that and get a nice refactor here. So this problem, this is a smart grid controller, and we have these data packets coming in. So a packet has like an ID, which is like the ID of the node it's supposed to go to. So this is a single node, and they're all kind of networked together. So the ID is the address, and that tells you whether to go left or right, basically, or higher or lower. And then there's the length, which tells you how many pieces of data there are. And then there's all the data in the data packets, which need to be passed along. So this has an incoming data packet, and then we have to look at the ID to figure out where the data packet goes and then send that data packet to that ID. And in the case where the ID matches our current ID, which is given by this chip here in the top left, in the case where that matches, we go send that to meter out in this node here instead of left or right. Okay, so what I did here was kind of examine the data packet. Let's see if we can bring up a data packet example down here. Okay, right, here's an ID, here's a length. So I sent the length twice. I didn't want to do any kind of weird branching. So all this loop does is it checks what our case is, 1, 2, or 3. Is that what I used? Yeah, 1, 2, or 3, meaning we're less than, greater than, or the correct ID. And then it passes along all the data it receives straight to where it's supposed to go. And all the data it receives includes the duplicated length. Right, if we only pass the length in here once, then we also have to determine like where this length gets sent, and then that becomes 2 different branches. I couldn't really figure out a way to make that nice. So it's easier just to like duplicate the packet and send the whole thing over to one of the 3. But this here is obviously too much code. So let's look at what we're doing, and let's start by cleaning up what we have here. So we wait on x1. Why x1? Oh yeah, x1 just going to be any of these inputs, meter in, lower in, or higher in, right? And the first one's going to be the ID, so we save that in our accumulator. And then we compare it against the ID of our current node. Yeah, that all seems fine. And depending on the value there, we send a different case over to this chip. And then there's this, in this loop here, move accumulator, close accumulator. Okay, so we send the ID over. Let me comment that. So we send the ID over. And we wait. Okay. Accumulator was really just the ID. We haven't even looked at the length yet. Okay, so it's the second chip here that ends up looking at the length. So this only takes the first piece of data from whatever packet is coming from these 3 inputs here. So we save the ID in our data register. We get the length in our accumulator because we're going to be decrementing that, right? And then we copy that length over to our output chip. And then we pass over the whole packet starting with ID, length, and then the whatever length number of values coming from the inputs. Okay, so a few things here. ID is being passed along to here, is also being passed along up to here. We have a TCP, test compare. So what we could actually do is just compare. Well, and we do that, use that here. But I wonder if we couldn't just do that all the way over here. Actually, I know we can do that all the way over here. So that's one of the potential factors we'll use. And as far as this chip up here does still have more room. Like we could pass over the ID and the length directly over here. So this moves X3 to ID, and this moves data over to X2. So this just takes the ID that's passed to it and then passes it right along over here. So that's a thing we don't need to do. Except I suppose the reason we're doing that is because we first pass over the length. Wait, move data to X2. That is the ID. Right, yeah. Right, we're moving along the ID twice. So we examine the ID, we turn that into case over here, which we passed along. And then we take the ID, then we pass the ID down here, and then we pass the ID over here. So that is a bit of redundancy. I don't think we need. So suppose we just passed along the ID directly instead of a case. We'll start with that refactor and then we'll look at others. So I would have to use X1 as both an input and an output, which we can do. Okay, we can do that. So we move X0 to data instead of case. And this is going to be, we're going to move X1 to data, and this is just going to be the ID. It's always the ID. Or maybe, if we're doing it this way, we could just pass along the diff. Because we're comparing against the ID. Why not just subtract right away and pass along the diff and operate on the diff? Well, I'll think about that in a sec. Yeah. We'll start with this. So we move X1 to data. That's the ID. That's our current ID, actually. So we don't need to do that from here. Maybe we comment out this line altogether. Hold on. Right, here's an advantage of doing that. Instead of doing this test equal 1, 2, 3, we could do a test. Yeah, we could be doing the test compare here. had 2 lines for the positive case, 2 lines for negative case, and the second line being so that we can like jump ahead, right? And then in the neutral case, we have we just fall through to the neutral case. So maybe. What I'm going to do actually is we're going to make a copy of this and give that a shot. All right, and give me just a sec. Okay. X0 is just incoming data. On every loop, we're looking at this data here. Maybe we do want to pass over the diff. Let's at least simplify what we have here. So we do a test compare here. This is kind of like the diff. We compare it against the ID. We compare the chip, our ID against the incoming ID. So instead of a test compare, we could do a subtraction here. We'll try that out, see if we run into a dead end. So move x1 to accumulator, and then we're gonna sub. I think we will run into a dead end because we actually need that ID. This would work ideally if we could. Okay, taking a step back, here's my thought. So we might have a data packet, right, which has an ID and then a length and then a bunch of values. If we duplicate the first 2 elements of that data packet and then do our branching logic off of that, whatnot, then we can just send everything in the data packet over in this loop here, which is kind of what we're doing. Yeah, and then in this case here, we just have instead the length. Maybe we've already added 2. And instead of the case, we have the diff, and we're not using these case numbers anymore. Okay, so we're going to pass ID along to this, which will then pass it on to this. And we could continue to have this chip pass over all the data values over. We could at least make the code a lot smaller. And from there, we can go to like eliminating this chip altogether. So we move our x1 over to, yeah, we save our ID. That is fine. And let's also save our length. Well, we're gonna move our ID over. So we're gonna move accumulator over to x2. I wonder why not just pass it directly over to here. The reason being, when we move out to 3 different things here, and I don't want to have to branch for a single value as well. So this can't know the data it's also passing over. Like it can't also evaluate that data as like an individual piece of data. So we'll move the ID over, and we'll try subtracting x0. So this is our diff. And instead of having all this test compare, yeah, instead of having all the tests compare, we just have the diff. We can pass that along. Because all this does is choose to move our cases. So 3, 1, or 2, or greater than, less than, or equal to, right? So we can delete all that. That feels good. And we're going to move our diff. Move accumulator over to x3. Okay. Cool. And now from here, I suppose we take the length. No, we're just going to pass it on to this chip here. Accumulator over to x2. That's the ID. We don't need to do that anymore. We've already moved the ID over to x2. So sleep x2, x2 null. I can tell you that this iteration of refactoring is different than when I refactored it post-stream 2 weeks ago. So let's see if we end up in a similar place. Okay, so here we're waiting on x3. The first bit of data we get is the ID. ID, we're just going to save in data. And then x1, this is just from our inputs, is going to be the length. Cool. So we can pass that length over. So we're doing that already. Pass the length over here. So now in this case, the first piece of data we get is the diff. And the second piece of data we get is still the length. And we're still going to add 2 because we're going to resend the whole packet over. So here we have, yeah, we pass the length over. And then we pass the ID over. And then wait a second, no, hold on. Oops, let's undo that. Okay, so we store our data. And then we store our length. We pass along our length, which is fine. And then we pass along the first 2 bits of our data packet. The reason we're doing this add 2 here. So we pass on the ID and the length, and then we pass over everything else. Now this diff here. Based on this diff, so we can do a test compare. Yeah, instead of testing if it's 1, 2, or 3, we're going to do test compare, I suppose, our diff against 0. And if our diff is positive, now what direction was our diff? So we subtracted our own ID from the packet ID. So positive means we go to higher out. So in the positive case, higher out, which is x3. So move incoming data x0 to x3. In the negative case, we move x0 to x1. That's the lower. And then in the neutral case, we move x0 to x2. Okay. That is fine. Now we just need guards on this. So in the plus case, we jump ahead. In the minus case, we also jump ahead. To, I suppose, jump 1. S equal accumulator 0. We'll just call this like decrement. So jump to dec. That didn't save as many lines as I thought it would, but I think that will still work. And now this thing that's going on over here, there's this duplication of just passing this ID around repeatedly. And I think we can make it do without that. Oh, there's this end label here, which we don't really need anymore because we don't have a loop or a jump. This just sleeps and then then defers completely to x2. Or to this chip. So this sleeps, waits for that chip. This chip does its shit, and then moves back to this chip. Yeah, I think we could actually do this all just from this chip up here. So instead of moving, well, we move the diff over to x3. Yeah, that's fine. Well, actually goes to x. Yeah, the first piece of data we get over here is the diff. And the second piece of data we need to get is the length. We need to be able to recover this ID. So that was part of why we moved it over. So we moved the ID over to x2, and then we did subtraction. So what we could do instead, if we're not going to use this bottom chip, we get the diff and we pass that diff along, and then we add x0 to get the ID again, right? Then we move x1 to data. And in this case, that is the length. And we'll be looping based on length, actually. Basically, this loop right here. If we can remove all of this header stuff, which I think some data. So if we move data over to x3, cool, then we don't need all of this where we move ID and length over. Well, we still need to move ID and length. So we move the diff over to x3. We move the length over to x3. And we move the ID because it's the first element of the packet. So move accumulator to x3. Move data over to x3. And then we have our loop. We won't need these two. I guess we can move data to accumulator, and then we have our loop. So I'll move x1 over to x3. Sub 1. We're barely not going to fit. We're going to have to figure out something we can shorten up here. So test equal test of our accumulator, which is our length now, is equal to 0. And if it's not equal, we jump to the loop. And otherwise, this line we no longer need. Cool. Well, I think we've eliminated the need for this chip here, haven't we? So I think this is a different solution from what I got. That is also 2 chips. And it works. That feels good. That's a good warm-up. Get me back into it. Okay, great. So it's close. We still have 2 chips. I was able to get 23 lines of code and a little bit less power usage. So this is 27 lines of code currently. We can drop 4. I feel like somewhere in this whole mess, we can remove stuff. We need to pass over diff, then length, then ID, then length, right? And part of the difficulty here is that we calculate the diff, and then we recalculate it back to ID. What if we move the ID over to data and copy it into the accumulator, then get our diff that way? I think that will do us. Then we're not. Then we can just move our length directly into the accumulator rather than into the accumulator first and into data while we shuffle around values. So x1 over here, we're going to store our ID in data. And we're also going to store it. Yeah, I think I can just safely delete this stuff. We know what we're going for. Okay, so we store our ID. We also store it in the accumulator, data to accumulator, and then we sub x0 to get the diff, right? Then we move accumulator to x3 to pass along that diff. And then we move x1 into the accumulator. This is our length. We move length over to x3. That's this first iteration of the length there. Well, not length, rather accumulator. And then we do this loop here. And this time length is an accumulator, so we can math properly here. Okay. That bought us 3 lines of code. Let's give it a little simulation. Oh, nope, something is wrong. With x2, we forgot to send something. Okay, we moved the diff over, right? To x3. And then we move the length over. Oh, we need to move them again. So now we need to move data to x3. Move the accumulator over to x3. Right. So we move diff over, we move length over, move ID over, move length over. And then we do all this stuff in between. I'll move those comments. I'll just comment the output. Okay, I think that also works, but we didn't save as many lines of code as we thought we would. We're still actually, we were at 26, we saved one line of code. Power usage went down though. That's a new best. I think this works. So in the solution I ended up with, I had this chip over here, and I was computing the diff here on this side. And how would that work? I suppose on this left side, we just calculate the, well, we just pass the ID along. Well, I don't know. I am pretty happy with this. Let's just clean up the wiring a little bit. X3 goes out there. I think this cleans up better if we move down. Partially I'm cleaning up the wires as a way to stall while I think. But I'm not sure something will come to me. And here we can make all the labels readable. Okay, well, it's certainly an improvement. It's a lot cleaner. Two big chips down from 3 big chips is a huge improvement. And I can be happy with that. I can always look through my deleted files and compare against what I deleted some other time. Let me just stare at this a little bit longer. Okay, well, up here, I could reverse what I'm doing. So I copy ID into the accumulator, and I subtract x0. I could also put x0 into the accumulator and just subtract data. That doesn't save any lines of code, and it just flips the polarity. That doesn't do anything. this is the length, right? Yeah. I shouldn't have removed these. This is our ID. Okay. I'm happy enough with this. This gives us a diff. Okay, well, let's go into something new. Pocket I Ching Oracle. I Ching. Did anyone read the Golden Compass, that series? Is I Ching what was used there? Let me look it up real quick. Oh. Okay, well, anyway, it is used for divination. Whoops. So the Pocket I Ching Oracle. Have you noticed the I Ching, sometimes known in the West as the Book of Changes, experiencing a resurgence in popularity lately? For the benefit of those out of the loop, let me briefly explain. A hexagram is a set of 6 lines where each line is either solid or broken, with a total of 64 possible combinations. There's obviously much more to it, but I don't want to go into too deeply. I've been studying the system for a while now, but I wish there were a quicker way to generate hexagrams. I thought perhaps this ancient divination method may be brought into the modern era somehow as a pocket device. Okay, it's not sticks, it's lines. 6 coin flips it is then. Not at all. There's much more detailed process through which one arrives at the reading involving yarrow stalks. Okay, it is some sort of sticks. I stopped by to try to describe it to you, but you weren't at your desk. Suffice to say that we will need to generate the readings in the proper way if it is to be taken seriously as a divination tool. Okay, I found a part that works for this. It implements the physical yarrow stalk method in miniature. Wait, really? Strange. So we can just create the display for the result. Obviously, interpretation is up to the user. Oh. So there is an I Ching device. Already. And we're just doing a display. Interesting. Is this our first? I think we've had a display before. So button and oracle are simple inputs connected to a MEMS-based oracle engine. Okay, MEMS. I'm not familiar with that, so I've looked that up. Is a technology of microscopic devices incorporating both electronic and moving parts. Okay. So it's got moving parts. It actually does the stick shuffling then. Display is a display output corresponding to a custom LCD screen designed to visualize I Ching diagrams. I don't even know what they're supposed to look like. Let me pull up some I Ching diagrams. I Ching diagrams. And I can show what I'm looking at over here. Oh, I'm in the way of that. Hmm. Okay, that's enough of a rough idea, I suppose. I don't know how it corresponds to the physical devices. When the button is pushed, the Oracle engine will generate 6 values corresponding to the 6 lines of an I Ching hexagram from top to bottom. When the final value is generated, the display should be updated to match. Okay, so what are these two simple inputs? When the button is pushed, the Oracle engine will generate 6 values as like a data packet. So the button gets pushed, then the Oracle simple input. I guess this is the button. Let's just run this and see what lights up. Okay, so this is the button input. And those are the patterns. I don't know how to correspond those patterns exactly. But we have 6 values, I guess. 1, 1, 0, 1, 0, 1 in that case. The display should be updated to match. 6 values corresponding to the 6 lines from bottom to top. Okay, from bottom to top. Oh, I guess the lines appear here in the middle. So over here, in this case, no, this first one's just completely empty. This one over here, 1, 1, 0, 1, 0, 1. Oh, okay, so it starts off empty. Once this is completed, 1, 1, 0, 1, 0, 1. We get this image here. Okay. So it's not supposed to change until we get the 6th value. When the final value is generated, the display should be updated to match. Okay, it updates. Oh, we got a batch 6. I guess we could save it to short-term memory. We could get a little RAM module, save it there, and on the 6th, we just read everything from RAM into here. Now, how does this work? Okay, we have 6 inputs. Oh, Jesus. Well, we could use 2 of these DX300s. Yeah, this will allow us to turn. Where can I place this? This will allow us to turn 2 values into 6. I can't remember what the most significant bit is. Well, okay, this is 100. We'll see what it lights. Oh, okay. We'll figure out as we go. So we get like 100, 0, this is also a simple input. Can this be done? I don't think we can actually do it in one chip, but certainly with that many outputs, right? So we have something like this. But those can't be sent until later. We could have one chip read the first 3, save into an accumulator. We need 2 chips here. Well, we also... we read 3 values. We're going to read 3 values and turn that into one 3-digit number and pass it here. And then we're going to read another 3 values and then pass that here. So 2 registers can do this. Because we could save that first value to data. I mean, this is just not going to be enough lines of code, I'm pretty sure. But okay. I'm going to look back at, this is exactly what I'm looking for actually. So P2 is the most significant digit, right? Yeah. So 100 turns into 001, or 1 is on the P2. And I want to look at the digit set command. Wait, digit set. So we're going to set at 0, set at 1, set at 2. And if we're working our way up, so from the bottom up, we're going to get 0, 1, 2, and 0, 1, 2 for the second number. Set digit 0 to 7 does that, yeah. Set digit 1 to 7. And it does that to whatever's in the accumulator. Okay. So digit set. And it's all going to be between 1 second sleeps. So set 0 to, wait. It's going to be 1 or 0 depending on the value, the incoming value. So it looks something kind of like this. S equal, what's your input? P0 to 100. All right, and then in that case, we digit set 0 to 1. Otherwise, we digit set 0 to 0. Now, isn't there a nicer way to do that? I suppose we could just get the digit. So we could do something instead like this. Digit of P0. Where's our digit command? Yeah, we get digit 2 of P0. That puts it in the accumulator, which is where I was going to put the other thing too. So like digit P0, digit 2 of P0. Oh no, that's what's already in the accumulator. I see. Well, if we're gonna do it this way, so test equal P0 to 1. So now there's gonna be a sleep 1. And this thing should kind of be in a loop. But then we need 2 accumulators because we need 1 accumulator for counting. I don't know, maybe this approach is misguided, but let's just flesh it out, see what it looks like. So we're gonna sleep for 1 second. S equal P0 100. And then now it's a digit set 1. Digit set 1 to 0. And we sleep 1. And we test equal again to P0 100. And we do the same kind of thing. 2 1. 0, sleep 1. Right, and then I suppose we move accumulator over to data. But this needs to fit into a loop. And if we're building a number in accumulator, we can't also use accumulator for our loops incrementer. Unless we're like swapping back and forth repeatedly between accumulator and data. And I think that would bloat the loop to the point that it's not worth having the loop. Let's at least see that we're constructing the correct kind of number. We're just going to go ahead and move data out to x3. Okay. So we're starting to build a number. 1. Wait, we ended up with 1, 0. So this is the first thing we're getting. That's not right. So let's reset here. Okay, testing if our input is equal to 100. Oh, right, the whole thing starts by sleeping 1 second. Is this always gonna be the same number of seconds? So we hit the button, and then 1, 2, 3, 4, 5, 6. Tick, 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 tick. Okay, we sort of have to have an edge detector on the button. Rising edge detector. Okay, so we could have a small chip that detects that edge and then sends a signal to a chip to gather 3 numbers and pass that out. And then that chip will then again do the same thing, gather 3 numbers and pass that out. We could have like a control chip do that both times. So there's a control chip that waits for the button. And it tells the sub chip to gather 3 numbers and pass that back, right? And then once again, immediately tells the sub chip to gather 3 numbers and pass that back. And then the control chip sends those 2 numbers over to these 2 multiplexers. Yeah. Okay, cool. So our sub chip then is not directly connected, and we just use it twice. We don't need to implement this whole thing twice or put it in a loop, because a loop will come sort of from the control chip. Okay. So instead of moving accumulator over to data, what we do is just move accumulator back. So this is going to sleep on some input. Okay, sleep X on X0. Then I guess we move X0 over to null because we don't need it. And then when all is said and done, we're going to move accumulator back to X0 and pass control back to the control chip. Which could be one of these. Okay, but this thing needs to use 2 of its outputs to connect to these 2. Yeesh, it has to be a big chip, just because we need 3. We need a basic output. But no, we need a basic input. So we need a basic input like here. And then we need x3 and x2 as outputs. And then we need to communicate with our digit setting chip. Okay. It doesn't feel ideal that we're using two big chips. Like conceptually, maybe if I could figure out how to put this into a loop and a smaller chip. Or, you know, like this 4-line block of code, if I can make that simpler. Test if it's equal to 100. It'd be great if I could just oh well. Okay, well, let's use it. So we're gonna wait for the P0. Test equal P0 to 100. And if it's not, we sleep 1 second and then jump back to start. Right? Otherwise, we're good to go around bossing the controller. So we do it once, move null over to x0 or x1, and then we sleep to wait on x1, and we move x1 to data, so we store that, and then we do the same thing, move null to x1. I think we need to wait 1 second, so sleep 1 second. So move null to x1, sleep waiting for x1, and then move x1. This can go directly out, actually. So move x1 over to x3. Move data over to x2. And then we sleep 1 second after all that is said and done, and then we re-enter this loop of waiting for the next button press. Yeah. Okay. We are a little bit off. But let's see exactly how we're off. So here, this bottom chip is building up a number, 1, 1. It only got to 1, 1. So digit set 0, digit set 1, and then digit set 2, right? So we'll step through this one at a time. So we wait for the button to be pushed. The button is pushed. So now we can pass the signal over to the other chip. Okay, and we check if P0 is turned on right now. And in the case that it is, we set digit 0 to 1. Cool. Wait a second. Now check, it's still on, so we set digit 1 to 1. Great, wait a sec. Now it's off. Oh, here's where we messed up right here. This needs to be a minus. It looks like it's working. Hey, this was satisfying. Now, I'm sure there's plenty of room for optimization, but it's clean, isn't it? I'd like to think it's pretty easy to understand what's going on here. Okay, not bad. It seems like a lot of people use the same chip configuration that I did. I do have lots of lines of code, and my power usage is more than it could be. Well, now that we're only storing things in one register here, maybe we could use the other register for counter. This is where I suspect I have too many lines of code. Oh, you know one quick effect we can do here? We can just basically wrap this whole thing in pluses. So we don't need to have a jump instruction. This whole thing only happens. How do we do this here? I hate having like Emacs key bindings in here. Okay. So that should save some power, and it saves like a couple lines of code. Okay, we saved like 23 power and 2 lines of code. Cool. What else can we do here? We do have to sleep 3 times no matter what. Well, actually just 2 times. I wish we could be more direct with these 100s. We can grab a digit, right? So we can grab the 2-digit. So this very first one could just be digit 0, right? Let's look at it. So digit, isolate specified digit, and store the result. Okay, and since we're doing digit 0, cool. We just turn the first digit into that digit. So instead of doing test equal, let's look at this again. Okay, so instead we move P0 to accumulator. Move P0 to accumulator, and then we isolate digit 2. That saves us a line of code. Cool. Hey, and we dropped a tier. That's good. That's good. I wish we could do that again, that same kind of trick. But we can't move something to the accumulator for that. Like maybe we can move something to the data register and then we could add it. We don't have like a multiply or a bit shift. Oh, this last case here is actually just adding, right? We just add P0. Add P0. Yep. Nice. Nice. This is like getting to like hacky territory. Cool. That that's satisfying on the histograms here. So we get the three different digits in three different ways. We isolate the first digit, we check the middle digit, and then explicitly set the middle digit based on that result. And then we just add the value for the third digit. Okay. I think to get something shorter, we probably need to have a different approach altogether. So I think I've probably optimized this approach as far as it can go. Okay, I'm happy with that. And maybe I'll look at one more. I feel like I do need to call it a night on the early side. Splendid, how wonderful. How wonderful that such a device was created right here in China, where it all began. I'll probably even use this oracle myself as Shomei and I approach our wedding day. Oh, okay, cool. David is more Chinese than even a Chinese person. Uh, let's take a look at one more. Precision food scale. Precise dieting. Hmm. We have a weight. Hey, Zuno, how are you? It's been a while. I think I skipped out on 3 weeks, so it's probably been a month since I've seen you. I hope life's been treating you all right. A new semester? Hmm. Smartly Dark, how are you? Fair enough. Yeah, I've been pretty busy too. I've had a project at work that took a bunch of time, and I had some traveling. Traveled to do some dancing, visited Boston, visited New York. Um, that did also give me time to brainstorm a little. So I am thinking that my next big project. Oh, if I don't do if I don't do everybody codes, has anyone looked at that yet? If I don't do everybody codes, I think my next big project will be implementing the an emulator for Nanta Tetris and doing that on the front end. So doing that as a JS application. Yeah, I might dig into maybe what I might do. Let's see. Let's take a look at that and let's see how often it's running. Um, everybody.codes. Because this is like a shorter story, I suppose. Story 3, quest 3, part 3, stories. Melody made of code. So there have been 3 quests. And when did these come out? It started on the 3rd of March, and we only had 3. I could do these like a week at a time. I could log in next Monday and just do 3 stories. That'd be fun, kind of a revisit to Avena Code type stuff. Yeah, bite size. Um, I won't click on them and spoil anyone. I think so. How one thing I like about Everybody Codes when I've looked into it is that you can have a timer start based on when you click on the puzzle and start to read it. So you can still sort of have a leaderboard across time zones. Yeah, it's directly inspired by Avena Code. So if I understand it properly, like the main event is in November, but every now and then there are stories, and there's a story happening right now. So maybe I'll ask. We should spread the word on Twitch and see if other people know that's going on. And maybe I'll set up a leaderboard and do that next week. I'll just do that a week at a time. And I'll keep playing ahead for the project. I want to do Nanta Tetris and build the emulator in the browser. So it'll be kind of similar to Cinecore stuff. There's a game, Microhard MHRD. I'll pass this along. So Nanta Tetris kind of is in 2 parts. One part is kind of low level. You start with NAND gates um, and use a hardware definition language to build a computer architecture. And MicroHard covers that building up a computer architecture, and you're for the most part using like hardware definition language. So low level designing circuits for your memory, your ALU, um, and just controlling your CPU. The AntSim challenge thing, I have not, but AntSim sounds cool. Can you pass a link along? So MicroHard just does the first bit of that. So I have half a mind to revisit that as a game because when I want to build the emulator, I want to build. I'm not going to do like the data definition language and simulate the actual circuits. I just want to have an emulator for the hardware, for the memory and whatnot, and go from there because I want to build from the emulator up and build on top of the emulator a VM, the compiler, the operating system utilities, and eventually like build a game like Tetris or something on top of that and have that running in my web browser. So I want to have the compiler running in the browser and whatnot. And it'll be cool to like that to me is a more interesting half of the book is basically implementing um, a programming language that runs completely on hardware that you understand. And in this case, understand means like we've written an emulator for it. So that's going to be the upcoming project. But I don't know if there's interest, I'll do MHRD. But either way, like I can pass along this recommendation. I haven't played it myself. The reviews are okay. Um, the book that it's based on is excellent, and I would recommend that to anyone. I only did one. Um, I did a refactor of my last one, and I only did one puzzle here. But it's kind of satisfying, so I could show how that went. But probably I'm calling it a night early tonight. Okay, thanks. I appreciate the vote. Um, but yeah, also everybody codes. It'd be cool if we could get everybody code and definitely like pass that along on Twitch as streamers um if it's on their radar. I don't even know how I oh, I saw a Reddit post. I saw a Reddit post with like 0 comments. I just happened to stumble on it. That apparently it's happening right now. So not very heavily advertised. So maybe people, we're not the only ones that are late to the boat. Um, but this is cool. Basically, every time you click a button, this generates a six-digit binary number, and you have to pass that along to this display. Right, but not until you have all 6 digits. So what I did is I have this module here, and it extracts 3 digits at a time and passes that as one number back up to my main control module, right? So this control module waits for a button press. Once it sees a button press, it asks this for 3 bits to turn 3 bits into one number, into one 3-digit number. And it asks it to do that twice. Then once it has both those numbers, it sends one to this multiplexer and sends another one to this multiplexer. So pretty straightforward design. There were some little I did for getting these digits. So for the smallest digit, there's this command that isolates a single digit in the accumulator, right? So first I take the 100 that's coming in, and I isolate the 100's place digit. So that's going to be either a 1 or a 0 that stays in the accumulator. For the second one, I instead inspect the middle digit, and then I branch based on if, well, no, I don't inspect the middle digit. What I do is I check our input. Is it 100 or 0? Is it on or off? And if it's on, I set the middle digit of our accumulator to 1 or 0. And then for the third one, since the third one's already the hundreds place, I simply add that. And that was able to save me quite a few lines of code. So I'm not basically repeating this thing over and over again. But yeah, it was a fun one. It's like a pocket oracle. But I am tired. I'm still recovering. And, probably starting next week, I'll start streaming earlier. Maybe I'll start like at 10 p.m. That way I don't get as tired. Mm. So I think we should find someone to raid. Howling Fantods, we should say hi. I know, I know they do, especially when you have like a big project at work. Um, the time I start streaming on Mondays is like my usual bedtime on other days of the week. So I can handle that once a week, but if I also stay up late on Wednesday doing poker or on Thursday doing dance or something else, um then I'm in trouble. By the way, I'm doing a big poker tournament on Thursday, this Thursday. So wish me luck. It's like a $500 buy-in, and first prize is $2,500. So it's a small field that I'm very familiar with, and I think I have a good chance of landing top 3. So I'll let you know about that when it happens. But yeah,
Yeah, I don't know why that's not working. What the heck? Do I have to just like add it again?
he's playing with OBS right now. Why can't I hear? Yeah, thank you, thank you. And good to see you after a while.
Oh, what? My is the
Oh,
webcam not
wait,
connected?
PMC, the Ant Sim challenge. Let me just look that up real
I don't
quick.
see it in here.
Ant
What the hell?
Sim challenge. If you're still around, you might need to pass that link along to me because
I don't know
I'm
why.
not familiar with it.
You
But
like it.
Ant Sim sounds interesting. It reminds me of a fun project I did in college,
Hold on. Let me
and
unplug it and then re-unplug it.
it's kind of like an inspiration for a game idea I have floating around in my head. Um, but thanks for the rec, Sparkling Dark Matter. Thanks for stopping by. Maybe it's that one, but ants are cool. I was doing okay. I won't go into the full story, but I was doing I had like a maze solving creature, dev.moment.com. Wait, you're not the same person.
Now can you sense it?
I'm not sure this is a link I should open.
Okay. All right, we're back.
Let me do it in another browser.
Okay, we're back. Okay. Okay.
Anyway, I was doing a simulation of like a maze solvers as a group,
Oh no.
um, and I ran into a
Okay.
bug where I was like laying down kind of a pheromone trail as my various agents were exploring the map, and I would like merge them. I'd merge all the trees that they're creating, and then I would take a single node so I could get all of the ants to go to any single point on the map, right? But then I ran into bugs where I'd accidentally get my pheromones to go in a loop, and then my my agents would all just go into an infinite loop. And I thought, well, okay, maybe that's probably possible with ants, and that's when I learned about ant death circles.
Where's the
So the
chat?
thing I was simulating when I ran into a bug, my ants were all just going in an infinite loop, and it turns out that's a thing real ants do.
Ah, okay, all right. That seems fine to me.
So I
I don't know what that was. Sorry about that.
learned about it.
Nobody's gonna know.
Yeah,
Nobody's gonna know. They're gonna know.
yeah, you can accidentally end up, and they might just do that
How
until
would
they
they know?
die, or until like enough people leave the trail that they're not like reinforcing it.
Oh, gotcha. Okay, all right. Okay, go back.
But it seems kind of
Well, I was
broken
using
that
it for
that's
food, so
possible,
I
but
would say like
it
wild
makes
check.
sense.
I'm gonna go through. I don't really need a level traversal, do I?
All right.
I don't think I necessarily need to store like
Yeah.
the
That was
levels.
funny. I think I burst out laughing when I saw that I was doing the same thing my code was doing.
But I do
Nature has
need to
bugs
check to
too.
see. I do need a valid set, right? If I have a valid set,
Alrighty.
I
Well,
know
thanks for stopping
DQ is
by.
set to 0.
Have a good night.
So maybe I could say like, yeah, I mean like that's what valid is. Can make 0, right? So I'll have DQ, which has my perimeter values, and what I would have to do is pop. Hey, what's up, Stu? Dude, Stu, I haven't seen you in a while. How's it going?